Now, I am going to solve a few examples, one or two, and make remarks. Example 2. Say for instance, you are given something like this, given at log to base b of 3 is equal to p, and log to base b of 6 is equal to q. Express log to base b of root 1 over 2 in terms of p and q. Now this problem has its foundation in the definition, and as such it's somewhat technical, but it's still cool. So given something like this, the answer by definition we call it that if x raised to power n is equal to y, it implies that log y to base x is equal to n. Now, I am using different letters. It's whatever appears to appeals to you at the time the problem is being solved that you can use. The most important thing is that the presentation is consistent. Log to base log to base x of y is equal to n. So from what we have, it implies that 3 is equal to b to power p and 6 is equal to b to power q. So if we decide to divide 3 by 6, because what we have in this presentation suggests to us that we are supposed to have 1 over 2. So I am not suggesting that we have both in powers of b. So we can answer. It implies that 3 over 6 is equal to b raised to power p divided by b raised to power q, and that takes us back to indices. So it implies 1 over 2 is equal to b to the power of p minus q, indices also. So if we decide to take the logarithm of this to base b such that log of 1 over 2 to base b will now be equal to p minus q, right? But what we are told to express in terms of p and q is the log of root of 1 over 2. So this is a deduction. This does not have a direct link. This is a deduction. So if we know that the logarithm of half to base b is equal to p minus q, it implies that log of root 1 over 2 to base b is characteristically equivalent to log of 1 over 2 to base b raised to power half, which is still the same thing as this half now comes to the back from one of the laws of logarithm that says log x raised to power n to base y is equal to n log x to base y. So this is half now to the power of half. It now means that, and it's from the law of indices, don't forget that we understood that anything raised to power half is as good as taking the square root of that number. So this half will now come to the back. Half of log 1 over 2 to base b. Now already we have log 1 over 2 to base b to be equal to p minus q. Therefore, half of log 1 over 2, because log root half to base b has now been presented to mean that half of log 1 over 2 to base b. And this 1 over 2, already we know what log half to base b is, which is p minus q. So half of log 1 over 2 to base b will now be half of p minus q. This is the simplest solution. If you like, you can still expand it, but at this point, any examiner is supposed to be, satisfied that you have arrived at the solution. Now, like I tell whoever cares to listen, even if you take it further, you have no penalty for that, except for the fact that you are going to waste your time. So that takes care of this. Mathematical problems come in different dynamics, but the more consistent you are with solving them, the better informed and tactical you become when it comes to solving mathematical problems. You observe that a lot was deduced from indices in the course of solving this problem. That is how mathematical concepts are. So if you are learning any concept in isolation, you are doing a disservice to yourself. But like I tell whoever, most of the time, like I maintain, our teachers most of the time don't emphasize. Maybe because they just want to see to it that they finish the scheme of work. It's only God that understands. But then, to me, it does not make sense for one to finish the scheme of work and an average candidate cannot get a minimum of 60%. Then, it doesn't make sense. So, that is it.